Hey everybody, this is Larry. This is day 22nd of June of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Cave largest element in an array, which is taking its time loading. Technology is hard. How's everyone doing? It's rainy here in New York, so I wouldn't say I got soaked, but I am a little bit wet. So yeah, hopefully I get to solve this problem quickly and just get it over with. Unfortunately, I don't know what's going on here. What's everyone doing? I'm just. Let me refresh. Maybe refresh will work. Oh, there you go. All right. Sorry for the long intro, friends. Try to do these live and try to just be as fresh as possible. Anyway, so given an array numbers the cave largest element in the array. Note that cave largest element in sorted order, not the cave distinct element. Okay. I mean, there are always a couple. I think there are variation on this problem. That's why I'm like trying to think about what to say. And but that said, this is a very standard problem. The cave largest element, so you just have a min array of the elements and then remove them, right? So that's gonna be log k for each element to n log k. So the variations that you can see is that maybe you need to do it multiple times. Maybe you need to, maybe there's some weirdness with distinct elements and stuff like this. But for now, I feel like it should be okay. I feel like we should be able to just make it a standard heap problem of and then the first question about heap things is whether it's just thinking about whether it's a max heap or min heap, right? A max heap has the max number of the thing and a min heap has the min element, and here we want the min heap because we want to have we want the heap to contain all the largest elements, so that when you remove it, you remove the k plus one biggest element and so forth. Of course, you can also sort and then just like return k, but you do lose some in the log k versus log n, which if I was in an interview, if I was on competitive, it doesn't matter, right? Because log k, log n usually it doesn't matter. Sometimes they could write in a way such that matters, but for the most part, it doesn't matter. Because log n and log k is just like way small difference in general. That said, if you're in an interview, they will always, if they know what they're doing, they will ask you about it. Or if they're nice, they'll ask you about it. If they don't, that means that they probably already gave up on you a little bit, or maybe they just like bad at interviewing, which is also possible. But in any case, so try to do it as optimal as you can. So let's get started. So heap is you go to a heap. So we want a max heap, as we said, and we get a min heap here. So let's write some helpers here. So we have a thing, and the thing that I do with heaps, and one thing I would also say is that this is a way, maybe this isn't a good thing, because I think in other languages you can overload the sorting function or the comparison function. In Python, not so much as far as I know, which makes it kind of painful, to be honest, because then we have to resort to hacks like what I'm doing now, where it by default it's a min heap. So to get a max heap, you can think about multiplying every number by -1, and therefore in the push and the pop I have the negative here to kind of so that it's easier to think about and use as an abstract data type. But yeah, okay. So then now we have for x in nums, we can say, we push x, and then now while length of heap is greater than k, we can pop, and that's really all that is. And then we return h of the top, right? Because the top we have the smallest number, and I'm just looking at the constraints really quickly to make sure there's no weird edge cases like like nums have 0 or k is bigger than nums or something like that. So otherwise, this looks okay. Let's give it a quick submit, not submit, but run test. And this is why we run test, because of easy typos. I always forget that. Not gonna lie, the Python heap thing is a little bit weird, and I don't know why that they don't have it in a standard library with very well designed things. Maybe they are, and I'm using like an old one though, to be honest. Oh, you have to. Yeah, they just return pop. So this seems, maybe I'm off by 1. The k smallest number. Okay, so that means so k is basically 1 indexed, right? So what we want is actually k minus 1. So yeah, so let's do because that means that we want to remove the kth element. So I think here we, oh, did I messed up? So we want exactly k elements. No, this should be good, right? Did I mess up? Maybe I messed up somewhere. Okay. Yeah, the top element should be the smallest. Wow, man. Maybe I am more red than I thought. Okay, did I mess up? K is 2. Output is 5. Oh, largest. I returned the smallest for some reason. How did I return the smallest for some reason? Dong dong dong. I did the one cube now max heap. So then if you have more than 2 elements, it should be okay. Why am I returning the wrong thing? Maybe I have some signs wrong. -1, -2. That's weird. So we want a max heap, right? Oh no, sorry. I said that we want a max heap. We actually want. I don't know what I said. I think I confused myself. We want a min heap, but then I think as a result of order talking about push and pop, I think I confused myself with getting the max and the min. This is very clearly it's very easy to mess up, but this is why you have good debugging tool, and as you debug, then you can go. Wow, this is kind of embarrassing because this is literally I would try to put emphasis on it, and I got the wrong one. But yeah. Why did I think I want the max heap? Okay. I think this is a very common mistake, and I guess obviously even I make it from time to time, even when I need to look for it. I wanted the max numbers inside the heap so that the number, but we wanted to sort by, or not sort, but we want the last number or the top number element to be the min element of everything in the heap, so that you drew a line for it. I think I don't remember, but I thought I explained it correctly, but then at some point I confused myself and I switched. But oh well. I mean, it's a easy fix, and this is why we do the thing. But yeah, 813-day streak, bound to make some mistakes though. I feel like I've been making a lot of mistakes lately. Maybe I just need to take a break or something. But anyway, yeah. So what is the complexity, right? Well, H will have at most k elements, because if it's more than k, it breaks. And also this could be an if statement, but I like writing it as while, because maybe there's some cases where I muck around on the beginning, and then in this case the invariant after this will always be true. I don't have to verify it. There's a minor cost an if statement versus a while loop, but it's usually minor enough that I don't care. But yeah, we'll always have at most k elements. Otherwise, so it's going to have all of k space. And in terms of time, because each of these will have at most k elements, each of these will have at most log k. And with n elements, so this is going to be n log k, right? So yeah, that's pretty much it. That's all I have. This is you must know this for an interview. It comes up all over the place. In fact, I wouldn't expect this problem in an interview because it's too easy or too basic. I mean, if you have done it in a few times, you'll see it, and yeah, you just have to do it. And there are problems that build off this, so you really have to know it and know it well enough to solve harder problems. whether and this is universal, I think, not just like because I know that some countries have harder OAs, online assessments and stuff like this, but this is just very basic, so I definitely recommend you getting into it. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.